Hello, welcome to Module 2, Lesson 9 of our CASP Plus course. On this lesson, we're going to talk about forensic analysis tools covering the following topics, like file carving tools, binary analysis tools, imaging tools, hashing utilities, and live collection versus post-mortem tools. So, just an introduction, we must put together a forensic toolkit now that we have solid understanding of many types of evidence that can be gathered and the analysis that can be carried out. We must make sure that the instruments we employ are acknowledged as legitimate tools and that they are applied properly. Like for instance, a bit-by-bit copying program is required to take a forensic picture of a storage device. When preparing images or templates for an operating system distribution, we wouldn't utilize the same tool. So in this lesson, we're going to talk about some typical forensic analysis tools. So first is a file carving tool. So these tools allow a forensic investigator to search a live system or forensic image or hidden or deleted files while fragments and with file fragments and their contents. Their two tools are suitable for this process, which is shown as follows: the foremost and the strings. So for the foremost, so the ability to recover certain file types from the file system after they have been erased is provided by first, file fragments in a wide range of forms such as documents, graphic formats, and binary files will all be searched for. It can recover deleted files from a forensic image or the live file system. So as you will see on the screenshot, right, it shows, so the following screenshot here shows the help for the foremost command. Okay, so now here's also an example using the foremost command. So in this example, we're searching the fixed drive for the .pdf and the PNG file types. Let's talk about the strings. So this is also a helpful forensics tool for looking for ASCII or Unicode strings in picture files or memory dumps. Most Linux distribution comes with this built-in tool. The following screenshot shows the options for the strings command right here. Now, in this example, we're searching with a binary file where we need to see if there are any embedded copyright strings. We are using the strings command to search for all the strings within Python 3 and piping the output to the grep command to only display strings containing copyright characters. Now let's talk about binary analysis tools. So the information and the logic employed in binary files can be found using a variety of tools in the forensic toolset. Since the source code for these files has been compiled, we're unable to study them. Instead, we must utilize analysis tools to look for references to other code modules and libraries. We can also dissect the logic of binary files using reverse engineering methods. There are numerous binary analysis tools, for example, some of which we'll explore right away. So here is a hex dump. So in here, we can access and examine the data kept in flash memory by using the hex dump. When we need to extract data from a smartphone or other mobile devices, it is frequently used. A link between the mobile device and the forensics workstation will be necessary. A hex dump may potentially show previously deleted information, including an overwritten SMS messages, contacts, and saved photographs. Next is a binwalk, because it will search binary images for embedded files and executable code. Binwalk is a helpful tool in computer forensics. The tool's output can be saved in a folder or for later analysis after use. Additionally, it can be used to compare files for shared components. So, in a recently found suspicious file, we might be able to find signatures from a known malicious file. The payload's contents and offsets in decimal and hex will be shown in the output. So here, right, in this screenshot, it shows the output of a binwalk command. Okay. Next is a GIDRA. The National Security Agency created GIDRA as a tool for reverse engineering. It consists of software analysis tools with reverse engineering capabilities for compiled code. It is a strong tool that supports numerous widely used operating system platforms and may be automated. It is made to look for harmful processes hidden within the binary files. Next is GDB, or the GNU Project Debugger. So when running compiled code, developers can identify and correct errors, and thanks to debugging tools. Information about programming errors that lead to unexpected results or make code unresponsive can be useful. Other running code modules that can compromise the stability of your code can also be displayed by debuggers. GDB is compatible with several popular operating systems and supports popular programming languages. Next is OllyDBG. So OllyDBG is yet another well-liked reverse engineering tool. It can be used for virus analysis as well as troubleshooting built code for developers. By breaking the software code, enemies may or attackers may potentially utilize OllyDBG to steal intellectual property or IP. Now let's look at more analysis tools. So forensic toolkits are comprised of tools that can analyze file systems, metadata, running operating systems, and file systems. And we need advanced tools to detect the APTs and IOCs that are hidden within our information systems. Let's look at some of the examples. So first one is the XIF tool. So we will require a particular analysis tool in order to see or update a file's metadata. JPEG, MPEG, MP4, and many other well-known image and media formats are among the many image formats that XIF tool supports. To extract metadata from a picture that has been downloaded from a website, you can use a specific command called like this one, XIF tool NASA.jpg, right? So if you run that, this will be the output, right? So this information is actually very interesting as it displays details of the photographer, this one, right? And their location and many other details, right here. Nmap. Operating system and services can be fingerprinted during analysis using Nmap. This will make it easier for security experts to identify the specific versions of the hosted services, such as DNS, SMTP, SQL, and others, as well as the operating system's build version. Next is AirCrackNG. So we can use AirCrackNG to evaluate the wireless network security. So with this program, you may attack using packet injection and decrypt WEP and WPA pre-shared keys while also keeping an eye on wireless traffic. Volatility to locate memory resident artifacts during forensic examination. The volatility tool is deployed. The majority of popular 32-bit and 64-bit operating systems, including Windows, Linux, and macOS and Android, are supported. So if the information is in the form of a Windows crash dump, a hibernation file, or a virtual machine snapshot, it is very helpful. Next is SleuthKit. So this utility is a suite of applications used to examine forensic photos via the command line. Typically, it is included in graphical forensic toolkits like Autopsy. Imaging tools like DD will be used for the forensic capture. SleuthKit may be used with both static images and live operating systems because it supports dynamically linked storage. It can be helpful as a real-time tool when dynamically coupled to operating system disks, such as when responding to issues. Now let's talk about imaging tools. One of the main objectives when choosing imaging tools for forensic investigation is to select a tool that will be accepted when presenting evidence to a court. Additional tools such as hardware write blocker are essential because not all imaging techniques ensure that the original will be fully unharmed during the imaging process. When there comes time to present the evidence in a court of law, the following tools are frequently used. First is the FTK, or the Forensic Toolkit Imager. So Windows operating systems provide a simple-to-use graphical utility called the FTK Imager. It has the ability to produce photos in common formats as EO1, SMART, and DD-RAW. It enables hashing of image files, which is crucial for integrity, and also keeps a log of the entire imaging procedure. Next is the DD command. Numerous Linux distributions provide the DD command as a built-in feature. It is sometimes referred to as a disk dump or a data duplicator. Although the utility allowed for the acquisition of memory dumps on earlier versions of Linux, it is not possible to capture a full dump of memory on a contemporary distribution. So, it is also important to utilize hashing tools when working with files and images so that we can recognize files or images that have been modified from the original. A hash is a data piece checksum. So before cloning, we can use a hash value to record the present state of an image, and then we can hash the cloned image to confirm that it is the same. A database of well-known hashes for our operating system and application software can be used in forensic analysis to find any anomalies. Operating systems come with a variety of hashing tools as well. Most Linux distribution contains shaky length sum, which enables the checksum of a file to be recalculated using SHA-160, 224, 256, 384, and 512. Then for the Linux grep command, a SHA-256 is calculated in the sample below. Let's talk about live collections versus post-mortem tools. So to capture information that will be lost or overwritten, we must strictly adhere to the order of volatility criteria during forensic analysis, right? Now, after the data has been logged or recorded, we can use a variety of tools to evaluate and investigate it. So here are some popular utilities, right? First is a netcat. So installing netcat will allow us to run commands on a distant machine, right, or remote machine. To grant attackers remote access, netcat can be started as a listener or on a compromised computer. Additionally, it can be used in forensics to collect data with a negligible impact on the systems under scrutiny. Next is Wireshark. Wireshark is one of the most well-known protocol analyzer. It has a wide range of operating system platforms and offers a graphical user interface to security professionals. Wireshark allows us to record data in real time so that we may learn about typical traffic patterns and protocols. Additionally, we can load packet capture files for in-depth investigation. It also has a T-Shark command line counterpart. Using Wireshark, the following screenshot displays a packet capture. It's in here. So the exhibited packets in the sample has been filtered to only include DNS specific or DNS protocol activity. Okay. All right. I think that's the end of the lesson. In this lesson, we spoke about the following: file carving tools, binary analysis tools, imaging tools, hashing utilities, live collection versus post-mortem tools. Okay. Again, thank you very much for watching the video, and this is the end of Module 2.